It's like I don't care about nothing, man. Yeah. Oh,
What's going on, guys? Now, this one is starting the new unit. So this is what we like to call the angle relationships unit. So we're going to be dealing with a lot of angles. We're going to also be dealing with a lot of proofs. So make sure you're taking the notes, listening, and I suggest pausing when you need to, practicing the problems, and especially at the end, if I tell you to do practice problems, make sure you do them, because it will make it so you're a lot more successful on our next test. So to start this packet, we have a foldable. Now you can thank my TA for already folding it the way we want it and gluing it on there for you. But
Yeah, baby.
But on the front, I want you to write conditional statement on the top left, converse statement on the top right, biconditional statement in the bottom left, and examples in the bottom right. So my suggestion would be, as you're going along, pause it so that way you can write it all down and hear whatever I'm saying.
Do you understand the words that are coming out of my mouth?
So when I ordered these, I didn't realize that I accidentally ordered the ones that already had the answers in the fill in the blank. So you lucked out on that. But for the conditional statement, a conditional statement is written in an if-then form. So it has to have a statement where it's using if and then. They can be true or false. So an example, if you work hard, then you will like geometry. So for some people, that will be true. For some people, you might still not like geometry. Now, a conditional statement has two parts, a hypothesis and a conclusion. Kind of reminds you of your science classes. So the way we read it is from P to Q. The if part is the P, the then part is the Q. And we'll eventually get to examples after I go through each of these. And then we got
No, that's it.
the converse statement. Now the converse statement is very similar, but what we're doing is flipping them. So what used to be the then statement becomes the if statement. What used to be the if statement becomes the then statement. So I gave you an example on this one. It says, if B is between A and C, then line segment AB plus line segment BC is equal to the line segment AC. So this is actually your segment addition that we did from the first unit. Now the converse of the statement you see is we just flip them. So if AB plus BC is equal to AC, then B is between A and C. So just like I said, it's formed by switching the hypothesis and conclusion. So it used to be from P to Q, now it's Q to P whenever you're dealing with the converse. So in the bottom left, we have the biconditional statements. So when a conditional statement and its converse are both true, you can write them as a single biconditional statement. So an example, if B is between A and C, then AB plus BC equals AC. And if AB plus BC equals AC, then B is between AC. So this is the example we used above. The biconditional statement is going to be the hypothesis, if and only if conclusion. So the hypothesis is this part. So if B is between A and C, if and only if AB plus BC equals AC. So instead of the then, basically we're saying if and only if to replace it. And then we
No, and then that's all I want.
And then?
then nothing else because I'm done ordering.
we are getting to the example. So first thing is conditional. So that was the first one we went over. So I'm going to give you an if-then statement. So if it is raining outside, then I will need an umbrella. So my suggestion would be to pause it and see if you get the correct answers, because what I'm going to do is just go ahead and put the converse and the biconditional on there now so it doesn't take up as much time. And now I've gone ahead and shown you the converse and the biconditional. So the converse statement is we just switched them. So if I need an umbrella, then it is raining outside. For the biconditional statement, we're assuming that both of these are true statements. Then for the biconditional, I'm going to say I will need an umbrella if and only if it is raining outside. So biconditional is the ones that say if and only if. So I'm going to break up page 2 a little bit. So I'm going to show you the first 4, and then
No and then.
And then.
No and then.
And then.
No and then.
And then.
No and then. Nigga really starting to piss me off, lady.
I am going to explain it. So as promised, here is the first 4. The first one, it says if A equals B, then if I were to do A plus C, it would have to equal B plus C. So this is the addition property of equality. So if you're saying that they equal the same thing, if I add them to the same number, it should be the same. Next one, they say A and B are supposed to be equal. So if I did A minus C, then B minus C should be equal. So that would be subtraction property of equality. And I just shorten property. You can if you want. You don't have to. The next one says if A equals B, then A times C should equal B times C. This is the multiplication property of equality. And then division, they say if A equals B, then and C does not equal 0, then A divided by C will equal B divided by C. And C cannot equal 0 because 0 cannot be in a denominator. So this is something that a teacher taught me before when I was a youngin', was if 0 is in the numerator, it's okay. If 0 is in the denominator, it's a no. So that might be a way for you to remember where the 0 can be when you're dealing with fractions. So we have the next 3, which is what I'm going to go over. I would go as far as saying that these are probably the most important out of all the ones on this page. So you'll notice that I'll highlight and star these because I think these are the most important things to know from this page. So like I said, I do think that these 3 are the most important things from this page. So the first one, it's reflexive property of equality or reflexive property of congruence. Now, the way we know which one to use, if it says something, so A equals A, so if it says the same thing equals something, we use the reflexive property of equality. If it says something is congruent, we use reflexive property of congruence. So depending on this symbol, we'll know which one. So if it ever says the same thing is equal to itself, that's reflexive property. So when you have reflexive property, only one thing is equal to itself. The same thing is equal to itself. The next one is symmetric property. So it says if A equals B, then B equals A. So if I wanted to give it a value, if I said A was 5 and B was 5, they're both equal. Doesn't matter which side of the equal sign it is, they're equal. So again, it's equality if they're equal. It's congruence if it has a congruent symbol. So this one, symmetric property, is used when two things are equal to each other. So reflexive property was when one thing was equal. Symmetric is when two are equal. Then the one directly under it, transitive property. Transitive property of equality / congruence. So just like the other ones, when they're equal, it's equality. When they are congruent, we use the congruence. Now, this one is when you have three or more being told that are equal. So if you see three or more things being said to be equal to each other, that's when we use transitive property. And again, these three, in my opinion, are the most important ones to remember. So we have four more. I'll go ahead and fill them in. Again, while you're doing this, I do suggest to pause, look, write it down, and then listen. Now, we're on the last four. So these are the ones like I promised. For the substitution property, it says if A equals B, then A may be replaced by B in any equation or expression. So basically, I can switch. If I know that the two are equal, I could put A anywhere that B is as well. So that's the substitution property of equality. Distributive property is when you, so if you ever see parentheses and we are multiplying it in, so I know a lot of you have seen from your teachers in the past this where they're saying what to multiply it into. This would be our distributive property. Angle addition, it says D is the interior of ABC if and only if angle ABD plus angle DBC equals ABC. So basically, basically if I add my angles together, that's angle addition. And the last one is actually one that we've had in the packet before, segment addition. So A, B, and C are collinear. Collinear meaning they're on the same line. And B is between A and C. If and only if AB plus BC equals AC. So if I add two parts of a line segment, they'll equal the whole thing. That is now the end of the video. So after this, to be successful, you should now know how to write a conditional statement. So an if-then statement. The converse, where we switch them. You should also know, especially on page 2, the three that I told you to highlight, star, make sure you know them. Reflexive property, where you say the same thing is equal to each other. Symmetric property, where two different things are equal. Or the last one was the transitive property, where you have three or more. Again, those are the ones we're going to use the most when we do proofs. So those are the ones that I want you to focus on and really know well.